Imagine a world without the technologies that we all now take for granted. Our parents may not even have imagined many of the things that now make our lives easier, safer, and more productive. But at some point, someone saw the need for every new technology and imagined how it could improve our lives. Someone had to design it, build it, and bring it to the consumer. The same is true for the blasting industry, and we all benefit from such innovation in one way or another. Today's blasters and explosives engineers have so many more tools previous generations could not conceive of. Blasting applications today are much more demanding in terms of safety, control, and outcome than in the past, which in turn requires better training and a more disciplined approach. Blast engineers can now utilize blast design software to model the blast from a three-dimensional perspective, allowing a virtual preview of the blast that predicts the outcome prior to the actual firing. This can be used to improve fragmentation, control blast vibration, and increase productivity while avoiding much of the trial and error process that historically was needed. These new software programs can be used in conjunction with the programming of digital detonators, photogrammetry, 3D laser face profiling, borehole tracking, seismic monitoring systems, and data collectors. Photogrammetry is an emerging technology that is changing the way many blasters work, allowing the blast engineer to photograph the rock face and to develop a 3D model in extraordinary detail and accuracy. This provides the blaster the information that is needed to place the right quantity of explosives in the correct borehole location to prevent unwanted noise, fly rock, and energy loss. This can also be accomplished with 3D laser profiling systems, which are typically set up in front of the blast face. User-defined points of measure are recorded, and an accurate profile is printed and given to the blaster so that each hole can be custom loaded according to its actual burdens. Borehole deviation measuring systems are becoming commonplace, and in many cases are now required. Often referred to as bore tracking, this technology measures actual borehole deviation from the drill plan design. This data can be used in conjunction with photogrammetry or laser profile data and imported into the blasting software, allowing the blaster to design and execute a much safer blast. Electronic detonators and their unique initiation systems are becoming more common as the technologies continue to advance and evolve along with industry needs. As blasting requirements become more stringent, the demand for greater accuracy, flexibility, and safety must also continue to evolve. These systems can be programmed in millisecond delay increments within an accuracy of 0.1%. Electronic systems allow for two-way communication between each detonator, the testing, and firing equipment. This allows the blaster to verify that each detonator is connected to the blast network, functioning, communicating properly, and programmed with the correct firing time prior to initiation. This helps to reduce misfires and produces a safer, more efficient blast.
One of the effects of blasting that inevitably affects people close to the operation is ground vibration and air blast. Blasters have sophisticated seismographs that accurately measure and store this data so that a blaster can see the results in real time and adjust the blast design accordingly to minimize and control vibration and noise. Most states and municipalities today require vibration monitoring and reporting. And throughout the years, acceptable limits have become more stringent at levels far below what would normally cause damage to neighboring structures and utilities. The start of any good blast design begins with accurate drilling programs. Today's drilling equipment is becoming more advanced, with smart drill technologies which are now able to monitor rock hardness, identify voids, cracks, and mud seams in the ground, along with other discontinuities within the rock in real time. These new smart drills provide explosives engineers greater information to make better decisions on explosives placement and blast design, in addition to greater drilling efficiency and a safer blast. Many drills today can also be equipped with GPS technology, allowing for blast design coordinates to be sent directly to the drill for higher accuracy in hole placement and drilling efficiencies. GPS technology can also be used to provide blast hole locations for bulk explosives loading trucks and satellite tracking of delivery trucks and equipment during the transportation of explosive materials on our highways. Inventory management and control system records are required by regulatory agencies and are also becoming more accurate as the need for explosive security increases throughout the world. Software programs and technologies are available to track and trace explosive materials from the point of manufacture through shipment, receipt, and distribution. If explosives are lost or stolen, they must be accounted for quickly. Although these types of incidents are extremely rare, it is essential for the world we live in. The IME SAFER Quantitative Risk Assessment Program is an invaluable tool to help safely position explosive storage and manufacturing facilities. This highly sophisticated modeling program, based on many years of empirical data, is in use and recognized by industry experts and regulators for keeping the public safe in the event of any unintended incidents. Our parents may not ever have imagined the level of technology available to us today. We might not have imagined either. But the technology used to ensure explosives for safe and efficient work in the form of our power tools provides each of us with products and services we have come to rely on. It is truly impressive.